Alright, let's begin our revision on the water cycle. Now before we do that, we must remember the idea of heat gain and heat loss. So what happens when matter gains heat? Matter will expand and of course it can change in state. And what happens when matter loses heat? Matter will contract and of course matter can also change in state. Let's examine the effect by looking at this diagram. What if I have to apply some heat to a solid? Now I did not say it's ice, but we can imagine it to be ice. So what happens when the solid is heated? You will say that the solid gains heat. Now, if it gains enough heat and it reaches the melting point, the solid will change state into a liquid. Now, what if now I continue to heat the substance which has changed to a liquid? If I continue to heat it, how will you describe what will happen next? Of course, you will say that the liquid gains heat and it starts to evaporate. Now, evaporation can happen at any temperature above the melting point. Now, if you gain enough heat, alright, and it evaporates, it becomes a gas. Now, when it gains enough heat and reaches the temperature called the boiling point, the liquid will boil and change state into a gas. Evaporation happens at any temperature above the melting point, but boiling happens at a fixed temperature. So if the liquid that we're talking about is water, then the boiling point will be 800 degrees Celsius. If we're talking about other liquids, then the boiling point may be above or below 100 degrees Celsius, but it will always be fixed. So let's recap before we go on. When solid gains heat and reaches the melting point, it will change state into a liquid. We're talking about this part here. And when liquid gains heat, it will start to evaporate into a gas. And evaporation happens at any temperature above the melting point. And when liquid reaches the boiling point, it will start to boil and change into gas. And the boiling point is a fixed temperature. What if we do the reverse and start to cool the gas down? Alright, when the gas cools, it becomes a liquid. This process is called condensation. How does gas cool? When it touches something cooler than itself, it cools down and condenses. That's what happens when you breathe out onto a piece of glass. You notice tiny water droplets on it. Alright, so when the warm water vapor touches the cooler surface of the glass or the mirror, it cools down and changes state from gas to a liquid. What happens if we continue to cool the liquid? If we continue to cool the liquid until it reaches the freezing point, it freezes. It becomes a solid. This process is called freezing. How can you cool a liquid so much? Well, you can use the freezer that you can find in the refrigerator. And when it freezes, it becomes a solid. Okay, now let's examine the heat flow again. When you heat up a solid, it gains enough heat and it melts. When you heat a liquid, it gains enough heat and it evaporates. And then later, when it reaches the boiling point, it boils. Now, and for a gas, when you start to cool it, it will lose heat and it will condense when it touches a cooler surface and condenses into a liquid. Alright, and when the liquid cools down, alright, until a temperature whereby it turns into a solid, it freezes. That's called the freezing point. You will know that the melting point and the freezing point are exactly the same temperature. For example, for water, ice melts at 0 degrees Celsius. Water will freeze at 0 degrees Celsius also. Finally, we go on to factors that can increase the rate of evaporation. Let's take drying clothes for example. It can be any example like drying of plates, but let's take this example. So what are the 3 factors that can increase the rate of evaporation? Number 1, the presence of heat. Of course, you put it in a place where it's sunny, where it's warm, so it can dry your clothes quickly. So the moisture on your clothes can evaporate into gas and your clothes becomes dry. Of course, notice the clothes here are all spread out because you want to increase the exposed surface area. Finally, when you put in a place where it's windy, because the presence of wind will help increase the rate of evaporation. Let's look at question 36. Now, a group of students prepared 4 setups, A, B, C, and D as shown in the diagrams below. When salt is added, the melting point of the ice is lowered and the temperature of the melting ice is decreased. The glass jars and plastic sheets are identical. Let's try to unpack and understand this sentence by sentence. The first part, 4 setups. So when I see this, I know that I must make some comparison. Otherwise, why are there 4 setups? When I compare, I look at their differences and similarities. Next, now this part was confusing. Salt is added, melting point of ice is lowered. Now, I didn't learn this in class. Don't panic. Sometimes you'll be given situations that you haven't encountered before. However, you can always use the science that you've learned to understand this. For example, although you have not done this before, there are words inside that you know. For example, you know the meaning of melting point. You know the melting point of ice is at 0 degrees Celsius. So when the phrase the melting point of the ice is lowered and the temperature of the melting ice is decreased, that means that the temperature when you add salt to the ice, alright, will fall below 0 degrees Celsius, maybe something like minus 5 degrees Celsius. That means it will be super cool, because it will even be colder than ice cube, which is at 0 degrees Celsius. Now, when I look at the setups, I notice there are so many setups, and there are so many variables, alright, and not all the same. So how do I start comparing? Well, I must choose. So first, I would compare A and D. Because I noticed between A and D, there's only one change variable, which is the temperature of the water. The rest of it is the same. It's just ice, just pure ice, and water in a glass jar. So, since there's a plastic sheet touching the ice, I know that this plastic sheet must be the cooler surface. So when the warm water vapor that comes out from the water here touches the bottom of this plastic sheet, the water vapor will lose heat and condense into water droplets. But in which container will condensation happens first? Well, let's look at the difference. The water in setup D is clearly warmer than the water in setup A. And remember from an earlier revision that the presence of heat is a factor that increases the rate of evaporation. So therefore the hotter water should have to evaporate more, evaporate faster as well. So that means that if there is more water vapor in setup D, if there's more water vapor in setup D compared to setup A, because the rate of evaporation is higher here, then there will be more water vapor touching the cooler surface of the plastic sheets to condense into more water vapor first. So between A and D, I'm quite clear that in setup D, I will observe the water droplets on the cooler surface of the plastic sheet first. Now, I'll go on to compare B and C, because when I compare these two, I only see one change variable. The top bar is the same, constant, ice with salt, plastic sheet, glass jar, water at 70 degrees Celsius, and water at 90 degrees Celsius. In which container, in which setup, will you find there to be more evaporation? Yes, you're right. Right, if you use the same reasoning from earlier, you'll notice that the water in C is hotter than the water in B. So therefore, there will be more evaporation happening in setup C. If there's more evaporation in setup C, there will be more water vapor in the air that can touch the cooler surface of the plastic sheet first, which will condense into more water vapor in C. Alright, so between B and C, I'm very clear. C, if I compare just these two, I should see water droplets here first. Now, I'll compare C and D. Between these two, now, the water is at the same temperature, so I cannot be saying that, oh, which one is warmer. Both water are at the same temperature now. But how about the cooler surface? Which surface is cooler? I remember that the question tells me that when we add salt to ice, the melting point will drop, the temperature of this ice will also drop. So if that is the case, this surface that touches the ice with salt should be colder than this surface that touches only pure ice. If it is going to be colder, then condensation, so when the water vapor touches the cooler surface, between these two surfaces, this surface is cooler. So condensation will happen in setup C before it happens in setup D. Now I'm ready to answer the question. In which setup will the first drop of water drip from the underside of a plastic sheet to the glass jar? Well, it must be setup C because the temperature is the highest here. Alright, it's very high. There'll be a lot of water, a lot of evaporation, a lot of water vapor that touches the cooler surface, and this is the coldest surface. And then, of course, the more and more water droplet that collects here, there'll be more water droplet that will drip. Now, I'm going to explain. This is the tough part, but based on the explanation above, you only need to separate your answer into two parts. Part 1. In which setup will there be the most evaporation? Of course, part 2, you explain which one has the coldest plastic sheet. This is how you will answer this. The water in setup C and D are the hottest. So A and B is also hot, right? It's at 50 degrees Celsius and 70 degrees Celsius. So the water in setup C are the hottest. So the amount of evaporation in these two setups will be the greatest. Now go to part 2. As a plastic sheet in setup C is the coldest, it will be the coolest surface. Of course, we're comparing C and D now. When the warm water vapor in setup C touches this coolest surface, it will condense into water droplets first. And since there's a lot of water vapor, it will condense and it will form big water droplets that will finally drip into the container. Alright, I hope this helps you in the revision on the topic of water cycle. Have fun!